back to our channel. Today in this video we're going to be doing an end-to-end data science project. So we're going to be starting together, and the project is basically on customer segmentation. So we're going to be using DataCo Global supply chain dataset. So I got it from Cargo, and of course it's an open source data. So I really encourage you to also learn along by trying to type the code and also see if you get the same result. With me. So with this, you'll be able to learn pretty far much better than someone that's just watching the video. So this is the pipeline. Pipeline is very important because it shows the flow of like I don't start any data science project or data analysis without having a laid down pipeline or a drawing, a planning of how I want to do the analysis. So because this actually helps me, it helps my flow of thoughts to know that, okay, from this stage to this stage, from this stage to that stage. Without that, really, is what I've tried. Oftentimes, when I don't have a very well laid out pipeline, I end up developing nonsense. I end up developing rubbish, really. That is the truth. So this is the pipeline that we're going to be working with, and the title of the project is customer segmentation. So the next question you should ask yourself should be, what type of algorithm, what type of machine learning am I going to be handling in this project? So in this case, we're going to be using unsupervised algorithm, so which is the clustering part of the work. Then we're going to be using supervised algorithm also, which is the predictive part of it. So that after we've already developed a model, after we've already identified the clustering in our data, so then we develop a predictive model that could be used later for an unknown data to be able to classify, okay, this customer, these are the properties, the predictors value for this customer. What category does it belong to? So we just check that, and then and that could be used for subsequent application. So from there we get data, then we pre-process, we do a short explanatory data analysis. Then from there we go on to feature engineering, which is the most important part of it. This is when you're going to be selecting variables, the one you need, the one you do not. So the one you need to encode, the one you do not need to. So this is the most important part of it. So then after the feature engineering part of it, then we go on to cluster selection. So we're going to be using EBO method. This is important for us to be able to know that within the clustering, what is the optimum, cluster in this data set. Then after we have been able to identify the clustering, then we go on to develop a K-means algorithm to do the clustering. And so the number that we've already identified from the EBO method, then we do some cluster analysis to know the some statistics in our data. Then we go on to do category mapping. So we move from the numerical clustering to a particular name we want to give to each of the customer. So then we go on to develop a predictive model for future references, for future usage. Then we try to, of course, do some communication and reporting. So basically, that is the high-level explanation of this data science project. So from this now, let's move right into our Jupyter notebook and start the coding afresh. So we're going to be starting the coding of customer segmentation using the DataCo Global supply chain dataset. So what is customer segmentation actually? Customer segmentation is the process of dividing a customer base into groups with similar characteristics behaviors, or preferences. So in Python, you can use various libraries for data manipulation and clustering, such as pandas and scikit-learn. So for this project now, uh, customer segment is, I've done so many customer segmentation for the people that I've worked for, and this is very, very important. For instance, in sales, this is done very, very often because they use it for marketing. For instance, is when you are able to classify your customers, then you will be able to know the offer to give to particular sets of customers. So after you've done customer segmentation, you will know the customer that actually patronize you more, the one that are loyal, the one that spend a lot of their money buying your goods and services. So when you are able to identify them, it becomes easier for you to be able to offer a discount, to offer some kind of things to attract them more closer, so that you don't lose them. So basically, that is what customer segmentation is used for. It's mostly used for marketing and the likes. So so in this project, I'm going to be using a very good data set of DataCo Global supply chain. You can check online. So I got the data from Kaggle, and this is the link. So I'm going to be putting the link right in the description. So get the data. I say again, get the data and follow up. So let's begin. So the first step, of course, is to import the libraries that we'll be using. So we'll be using pandas, matplotlib, seaborn, cluster, the k-means algorithm. Then we're going to be using standard scaler because we'll be scaling our numerical variables. Otherwise, we could end up having a highly biased model. So I've actually uh, posted a video that deals with on this variable transformation. So you're going to see the link right above. So try to watch the video so that you will know how to deal with different types of data issues that we usually have in data science or data analysis using Python. I mean pandas in this sense. So then I imported this warning store because I want to ignore all manners of error messages that could be giving me issues. So I just ignore them. But that is not actually the real thing. So these are the libraries we'll be using, and then we move forward right now to load the data set to the Jupyter Notebook. So the next thing right now is to load and also check some key information about the data we'll be using for customer segmentation. So I have already downloaded the data, so and I have it right in the same directory where I have my Jupyter Notebook. So I'm using a rich CSV file and this additional parameter. So you might need to do it. But I did this because the data did not uh, did not load properly. So you might not need to use this if your data actually loaded correctly. So then from this, let's run and see. Let's run. So the next thing right now, let's check the first 5 rows of the data. Okay, cool. So this is what we have in our data. We have type, we have days for shipping, we have days for shipment, and the like. So many variables. So, but for us to know more about this data set, so we can easily just use info function for us to know the number of records and the number of columns that we have in the data set. So let's run this and see. Yeah, cool. So it runs successfully, and it's so in the data we have about 180,000 records. This is a very good number. It's a very good data to do this kind of a thing that we are doing because it's large enough. So then we have how many columns? We have 36 columns. So we are not going to be using all the 36 columns for this data science, of course, but we'll be getting the one that we need from the data, and then of course we have to abandon the rest. So and this is also done in data science. So the next step now is what we're going to be going to know more about the data. So the step three is actually the where we will be cleaning and pre-processing the data. So first and foremost, let's check if we have known values in the data, and then let's just sum it up and see for each of the column. Let's see what we have, and so good for us. Because we don't have any non-data in our data set, so we can move on. However, let's still try to drop none in case of in case of any ones, of course. So let's drop the non-values anyway. So let's run. Okay, so cool. So our data appears okay. So the next thing now is to move on to the next step. So we are moving right now to the feature engineering part of the project. So which I consider the most important part of data science. So this is where we spend most of the time trying to engineering the variables, the parameters that we'll be using uh, for our data science project. So in this case, first and foremost, we have to select the columns, the variables. Like I said, we have about 36 columns, so we're not going to be using all of them. So for this project, based on the goal of our project, because the goal of the project is to classify the customers of DataCo Global based on the sales, anything related to the money being spent by each of the customer. So we are using those variables. We are using those variables to come up with clustering, of the customers. So sometimes it depends. The variables that you're going to be using for your segmentation, it depends on the goal, on the what you guys really want to get out of the project. So sometimes it could be I've done projects whereby we use only one variable, which is sales, which is the sales of the product. So we use sales to develop customer segmentation, because our idea is just to be able to identify the customer that spend most and the one that spend least on a particular product. So, but in this case, I'm selecting about how many variables now, about 8 of them. So, and they are all related to the money spent by each of the customer. So in this case, we have order item quantity. How many quantity does this particular customer, how many quantity does he buy? So 2, the one that bought 1 or 5, there's difference between them. Then the sales for each of the customer, then the benefit per order, sales per customer. Check information about each of these variables. So they are all explained in the data set. So check on the cargo so that you will know what each of the variable actually stand for. So then the other item discount, the discount received by each of the customer, then the other item total, then the other date orders, then shipping date. So this is very, very important too, because this deals with the time that an order was actually placed and the time that it was delivered. So this is important because you cannot compare a customer that choose first class shipping compared to a standard one, or an economy shipping type. So with this, we can use this. We could actually use this as well for as a variable to be able to do the clustering of the customer. So basically, then we come up with another data frame called DF segmentation. DF segmentation. So let's run this and see. Okay, cool. So let's check add the first 5 rows of the data set of our new data set called DF for segmentation. So this is what we have. We have about how many column? 1, 2, 3, 4, 5, 6, 7, 8. So for each calculations that we do, we're going to add them to this data set, such as the order duration, such as the class of each of the customer and the likes. So let's do something like correlation analysis, a very brief one, to check how each of these variables actually correlate. So let's check. Let's run this. Okay. Yeah, we see some of them. Some of them are pretty correlated, you know. So and we could actually use them to do some clustering. So basically, for this part, we are still continuing a feature engineering part of the work. Okay. So the next part of the project right now is to calculate the order duration. Order duration is the time taken, the number of days between the day that the order was placed and the day that the order was delivered. So we need to calculate this because the shorter the order duration, the the higher the probability that maybe it was actually due to a first class shipping mode. So, and if it's higher, that means probably the customer actually subscribe for a standard or economy class of shipping mode. So, and how do we do that? So, what we need to do is to take the first and foremost, we convert the order date and the ship date to date time objects. So by using pd dots to date time. I have already done this in the video that I mentioned earlier. This is also right part of the data issues. So I posted a video on about, I think, 8 type of data issues that we usually have while working with data science projects. So I really encourage you to go through the video. This is good. The video is going to help you a lot on how to handle the most common data issues when dealing with data science. So I'm not going to be going in depth into this because I've already explained that in that video. So after we've converted these variables to date time object, so the next thing we want to do now is to create. Let's run this and see. So the next thing that we need to do right now is to create another column called order duration, and this column will be adding this column to our DF segmentation data frame. So, and how do we do that? We only need to subtract the date that the order was delivered. We subtract the date that the order was placed from the date that it was actually delivered. So this will give us the range between the number of days that it actually to deliver each of the orders. So we use .dt .days. So the difference between the difference between the date it will be converted to days, and then we will know the number of days for each order placement and the order delivery. So let's run this, and let's see if the column order duration has been added to our data frame. Yeah, cool. So we have it right here. So this is the new column that we just added, named order duration, and this is the number of days between the day that the order was placed and the day that the order was delivered. So yeah, so basically we'll be moving on still under the feature engineering, and what we'll be doing right now is that we have to select the numerical columns in this our DF segmentation. So we have to select all the numerical column and then do the scaling of them to prevent bias. As you can see, we have other item quantity in the they are just one or two, maximum 5. So where we have about 200 plus, 200 plus. So if we use this directly, our model will be highly biased. So right now, the next thing we need to do is to select the numerical columns, like I said earlier. Then, and this order item quantity, sales, benefit per order, order item total. So these are all the numerical columns in the data set that we'll be using for the model development. So we are going to be using standardized. We're going to be using standard scalar of scikit length to standardize each of these column. This is also part of the data issues that I mentioned in the video that I've been mentioning since the beginning of this video. So I really encourage you to watch the video. The link is right above here. So watch it and you will learn that these are most of the issues that you'll be encountering when you are dealing with data science project. So we use the standard scalar, and then we select the columns that we want to transform. And then we use scalar.fit transform. I've already done this in that video, so please just watch. So we have already transformed each of these data set, each of these variable. And the next thing that we do right now, let's preview it. So after we've done that, we have to convert it to data frame. Then converting it to data frame, we will now preview the first 5 rows. Look at this data and compare it with what we have up here. You can see the difference. It is the same information. You still have the same information right here. So just that the standard scalar has already transformed it for us to prevent biasing in our model. So the next thing that we need to do now is to use able method to find the optimal number of clusters, so which is also called cluster selection. So, and how do we do this? First and foremost, we have to create an empty list where we are going to store each of the value of k-means inertia, so that we know the one with the optimal number of clusters. So then we will run for each. Let's say we have let's run for about 10 clusters. Okay, so for I in the range 1 to 10, 1 to 11, then from this we run the k-means for each of these cluster number. And if you are someone that have been working with k-means, so you should know how this actually works well. So then we run for each of these value, and then we get the k-means value for that, then store it. Then we can now plots. So we will be able to see this kind of a bump or this kind of a ankle structure in our plot, and from that we'll be able to say, oh, I think we should be able to get a very good cluster with this number of so let's run it and see. So with each of the cluster, we can actually use able method to find the optimal number of clusters. So, and this is actually based on the within cluster sum of squares approach technique. So, and from this plots, we can see a kind of bump right here at cluster, what is that? 4. So we can see a kind of a bump here. So I'm going to be going for 4 clusters. So if you try to run it, this actually tells us that there's something is happening here. There's a kind of a diversion here. So I'm going to be going for 4 cluster for our K-means clustering. So having obtained the optimal clusters for our model, so we're going to be going for 4. So then we have to indicate that optimal cluster equals to 4. Then we will run our K-means clustering based on this optimal clusters. So and how do we do that? So let's say K-means is equal to K-means. Then we have to indicate the number of clusters, which in this case is 4. Then the random state here is just to ensure that each time we run this, we have the same result. So then we will now create another column, so to be added to our DF segmentation data frame also. Then from that, we'll be able to identify the cluster that each of the customer actually belong. So based on the predictors, based on these parameters that we use to develop the model. So then let's try to get the first 5 rows and see if another column called segment ID is already added. Yeah, cool. So this is our new data frame, and here we have already added order duration, and now the segment ID, so which represents the segmentation, the class that each of these customer actually belongs to. So the first one belongs to cluster 2, but this doesn't make so sense to me. So the next thing that we'll be doing right now is what we call category mapping. So we map each of these value to a name that will sound much more better in the real world. So and it could be, let's say we have elite customers, we have loyal customer, we have imports, we have and the like. So we are going to select random names like that based on my experience, based on how I've handled some projects like this in the real world for the companies that I've worked for. So that is what we're going to be doing next. So for this category mapping, so I have come up with some names. So for each of our cluster, so the 0, so we're going to be giving elite customers, core customers, loyal customers, and impulse customers. So I use the map function. So this function is very, very powerful. I use this very, very often. So, and what it does It's just that it maps each of these. It's just like a representation. So where it finds 0, it puts elite customers there. Where it finds 1, it puts core customers. So with that, we use that to create another column called segment category, segment cards. So then we had this to the DF segmentation data also. So let's check the first 10 rows in this data set and see how it actually looks for the. Let's just select the segment ID and segment card and see the kind of relationship between the two. Yeah, cool. So we can see that 2 is stand for loyal customer. Is it the same? Yes, right here. So we have 2 loyal customer. Then 3 we have impulse customers. So from this we have impulse customers. So everything is very okay. So this looks really practical, you know. So if you want to present this to anyone that you are working for, they will be able to know, okay, so okay, the loyal customer. So having entered the details of this customer, this is what we have. It shows that, oh, it's an impulse, oh, this particular customer is an elite, and the likes. So the next step right now is to analyze the segmentations that we just did. So we want to get some key information that we could actually present to our employer, to the company, to DataCo Global, that okay, this is the information that we've been able to derive from the analysis that we have done for the customer segmentation. So this is basically to get the percentage for each of these customer. What is the percentage of the elite customer in the DataCo supply chain data set? What is the percentage for core customer, the loyal customer, impulse customer? So how do we get that? We just do some kind of a slicing whereby we indicate that, okay, pandas only go through this particular column called segment cards, and then only the values that are elite customers. Count them for me by using the function length. So count them. How many are they? After you've counted them, then divide it by the total length of the whole data set. Then multiply by 100. So with that, we will get the percentage of each of these customer category. So, and that is what I did for basically for each of the customers, and from this we can actually print the percentage. We can print it to 1 decimal place by using this. This is what we call string formatting in Python. So by using this, we'll be able to know the percentage for each of the customer. So let's run this, and cool. So from this, we are now seeing that we have about 53.3% elite customers. We have about 22.4% core customers, and we have about 20.9% for loyal customer and 3.4% impulse customers. So this is very, very important because this information is very important for marketing. So with this now, the company can say, oh, cool, we have a very, at least we have about 50% of our customers that are reliable. So by the time you add core customers to it, this core customer also are customers that are pretty close to elite customers. Elite customers are people that buy like 5 quantity. When they want to buy a shoe, they buy 3. They want to buy jacket, they buy 4. They want to buy this, they buy large quantity. So these are elite customers. So by the time you add them to core customer, you're having about 70 plus customers that you can rely on and say, okay, I think at this point we can actually offer discount to this category of customer. So from this, we could actually just identify the customer ID, customer key information like email, like phone number, and the likes. We could actually infer them from the database based on these segmentations that we have done. So we know that, okay, these are the set of customers that we are actually focusing on for this promo that we want to do. So we are not focusing on loyal customer, we are not focusing on impulse customers. You could also design another set of promo or another set of marketing, another set of discount for this category of people too. So this is very, very important. I've done several customer segmentation projects. So, and this is going to help you, this is going to help the company to know what to do and for whom to do it to. So this is very cool. This is a very cool result. So in the next step, we're going to be doing some kind of visualization for us to know more about the segmentation result. So the next thing now is to visualize some key results from our segmentation, our model. So, and the first thing, first and foremost, let's just select the segment card and segment ID. Then let's sort the data by segment ID so that we can see the nice plots of a bar that shows the distribution of the customer segmentation by their parameters. So with this, let's plot this and see what we have. Okay. So this just shows us the distribution of the number of customer per each category, per each class of the customer segmentation. So we can see that elite customers have the maximum, as we have already seen here in this percentage. Okay, so we can see that we have up to about it's even close, it's getting close to about 100,000 customers for the elite customers, and about 40,000 customers. Then yeah, within that range also for loyal customer and the impulse customers. These are people that just randomly just buy things on DataCo. These are people that randomly just order stuffs, not that they frequently order stuffs on DataCo website. So yeah, so we might not be focusing on them so well for our marketing, for our discounts, for the promo. So I mean, that is how business works. So people are looking for people that they could actually vouch for and say, yes, we know that if we offer promo, if we offer discounts to this set of customers, they will grab it and will be able to get more money from them. So that is basically for that part. So this is a very nice plot. Then the next thing now is that we want to visualize the clusters. Let's see the cluster for each of the order item quantity, the item bought by each of these clusters, by each of these customer segmentation. So yeah, so this is also a very nice plot that is showing the plot of sales against the order quantity. So we can see for cluster is 0, we can see for cluster 1, 2, and 3. So yeah, basically, so this is also part of the thing that could be presented. Then let's have a box plot for each of the numerical variable, and let's see how that actually varies with the segment ID with each of these customer classification. Yeah, nice. So this is the plot. This is 0, 1, 2, 3, 4, 5, 6. For each of the numerical columns, so we plot uh, for each of the clusters for 0, 1, 2, 3, So with this, you could also get nice information from this box plot and see the distribution of each of the numerical columns for each of the segment ID. Yeah, so this is also nice things that you could actually get information from. And this is basically just showing the characteristics of each cluster. The first thing is to group the DF segmentation. We group by segment ID so that we get all the information grouped by the customer segmentation. So we now calculate the mean for each of these values. That is the numerical value. For each numerical value, we calculate the mean as per their segment ID. So then we create a bar chart where we could actually see how this the distribution of that. So yeah, so this is the plot showing the mean value for each of the segment ID. Sorry, I had to place this somewhere else. So basically, I just replaced I put the legend right here because it was actually covering up this. So the next thing now is the predictive model, so that this could actually be used subsequently, such as when they have the data for each of the parameters that we use, each of the predictor. So one could actually predict and say, oh, okay, this particular customer is a loyal customer. This customer is an elite customer. And how do we do that? First and foremost, we have to save the training model and scalar for future use. So we use joblib library. This is what I usually use. There are other library that you could use for that. So, but I'm used to this. I'm used to using job library, and I think, yeah, it's a bit pretty faster, and how do we do that? How do we save? We save using the dump function. Says that joblib.dump, then the name of the variable of the model, which is what we declared right up here as here. This is the name of the model. This is what does the main thing. So then we use that. So we use that. We save the k-means and then the scalar too, because each time you enter new data, it has to be scaled. It has to be scaled. So we save that model as well as scalar model.joblib. So when these two are saved, then we can go on to write a function that we can use to predict the category for new data. So we call that function predict category, and the input, the parameter will be new data. So first and foremost, we have to load the trained model that we've already saved. And how do we load? We use the load function from joblib library. So we load, then you indicate the name of the model. We load the k-means model, we load the scalar model. So when both of them are already loaded, then we go on to preprocess the new data. Just like the same process we went through when we were actually developing the original original customer segmentation data. So with preprocess such as scaling the data, we transform that new data you've supplied to this predict category function. Then after that, we predict the cluster group, such as using the k-means model dot predict. So predict this new data scaled. So from the next thing that we have to do right now is to map the category. So any cluster number that this actually generate, it has to be mapped to the name that we've already designed in our model, which are actually elite, customer, call, lawyer, impulse. So if this line of code returns 3, then it's going to print out that, oh, this customer that you have actually supplied is our data, it is actually an impulse customer. So and instantly you take your decision based on that. So, and how do we do that? We use the mapping technique that I told you earlier. So category prediction, then so we say, oh, we create a dictionary. So 0 belongs to this, 3 belongs to this, and then use the get function. So meaning that if each of these value fall within this, then return the name of that cluster based on what we have up here. And if none is returned, I mean, if the number returned is not in this category, then print out unknown category. So then return the category prediction, which will be this variable. So first and foremost, let's run this. Okay, nice. It's already saved. Then the next thing for us to do now is to run this code. Okay, successfully. So what we need to do now is to test this model and see if it's working. So how do we test? We supply the new data as we have in this function. We supply the new data. Let's say our new data is, we have these values for the other quantity, this value, this value. We supply value for each of these variables. And after we have done that, then we call the predict category function by supplying this data into it. So when you supply that, then you can print the category that the customer with this information actually belongs to. So let's run this and see. So it tells us that this customer information that you have actually supplied, it belongs to an elite customer category. So basically, we have done a very nice job on customer segmentation. And just like I said earlier, this is a very important project. You've got to just go through it, try to learn, because if you are someone that you are looking forward to maybe becoming a data analyst or data scientist, you will be handling different kind of projects, and this is one of them that you will find yourself, working on. So I've worked on several segmentation, customer segmentation projects. So I try to look for a data that is pretty close to what I've done, So, and that is when I found the DataCo Global Supply Chain Dataset. It's so real, it's so practical. It's so real, it's so practical. So, and like I said earlier, companies perform customer segmentation based on different purposes, the techniques, the approach that you will actually inculcate depends on the goal, on the vision, on what your employer is asking you to do. Oh, let's talk to our data scientist. This is what we want to do. And we don't know how you are going to do it, but this is what we want. We want you to use this information from our data to develop a customer segmentation model that we call subsequently use to classify our customer based on the informations that we have on ground. So we are done with the project. We are done with the project. So, and this is how to do, customer segmentation using K-means clustering. So, yeah, you might be thinking on what to work on or how to improve on the project. So I have actually prepared something very small. It's not mandatory. It's not mandatory. It's just for your own good to learn more. So and this the exercise says that use the similar approach in this project to perform customer segmentation using other variables such as latitude, longitude, sales, quantity, etc. Based on your choice. So with this, you will actually see probably maybe people that resides in the US uh, patronize more DataCo, or people that are reside in Europe or Africa or any part of the world. So you can also do clustering based on this. So and I'm pretty sure you're going to see a far much better result. And this way, of course, you will need to modify the code to learn, but not something much. You're not going to be doing much of stuff to edit. So try this. I believe this is how to learn and learn well. So good luck in your try. And if this video, if you have actually learned one or two things in this video, uh, try to like, try to subscribe to our channel so that each time we upload another video, you'll be notified, and also hit the notification bell because very regularly I'm going to be uploading more data science projects that you'll be able to learn from. And of course, you know that coming up with this kind of a project requires time, requires some kind of uh, thinking to see how to write the code and how to explain it to people that will be learning. So I will still post another video. I will post another data science project as as early as possible. Yeah, as early as possible. So thank you, and this is just what I have for you in this video. And do well to like, subscribe, share, and hit that notification bell. Okay, just for your own good. Thank you, and see you in the next video.